Hello, this is Mr. Stansbury. I'm going to take you through some of the problems on the 8B assignment. First one here, number one, find the area of this triangle here. Okay, we want to use our area formula, which is area is 1/2 BC sine A. So since this is angle A and its sides B and C, remember the whole idea behind the triangles here is like, let's say if this is big A, across from it is little a, big B, across from that is little b, big C, across from that is little c. So what we need in here is we need an angle and the two sides that make up that angle, the two sides that surround that angle. That's how we find this. If they happen to give you, like say over here, they said that, let's just pretend that this was 8 centimeters over here. You want to ignore that. For finding the area with this formula here, we do not need the side across from the angle. We just need the two sides that are right, that make up that angle. Okay? So, with that, we will simply plug that into our area formula. Area equals 1/2 B and C. Again, these are the two sides that are around it. It doesn't matter which one goes where because you're multiplying them together. So 1/2, let's just do of 9 times 10. And then times sine of the angle between those two sides, which is sine 40. So we can literally just put this whole thing right into the calculator as we see it. I'm going to do 0.5 instead of 1/2 times 9 times 10. And you can simply push, instead of cosine, we got to do sine of 40. And that should give us our area, which is 28.9. 28.9 its area, so it's going to be centimeters squared. Okay, for E, do the same thing. Area equals 1/2 of the two sides. Let's do 6.4 times 10.2. You can put it in parentheses like this if you want, or multiply like that, doesn't matter. And then we're going to do sine of 120 degrees. So put that into our calculator. 0.5 times 6.4 times 10.2. Let's make sure I've got that all right. And then sine of 120. And that gives us an area of 28.3 if we round it off. And this is going to be also centimeters squared. Okay? Number two, triangle ABC has an area of 150 square centimeters. Find the value of x. Okay, so simply we're going to plug in all the stuff we know. Okay, this one tends to trick people a lot, and that's not the intent at all, but it's giving you the area. So this 150 is going to go in for area. So really we're going to do this. 150 is the area. 1/2 of the two sides. We know that one of them is, say, 17. I was supposed to say 17. There we go. And then we know the other one is x. And then we can do sine of the angle, which is 68. Okay? So here's what I'm going to do. I'm going to do 1/2 times 17 times sine 68. So we got 0.5 times 17 sine 68, right? And that gives us 7.88. So we got 150 equals 7.88x, right? Divide both sides by 7.88. And that will tell us what x has to be, okay? So actually I already have that in there, the unrounded number, which is better than our rounded number. So I'm just going to do this. 150 divided by second answer gives us 19.03. Does it say where to round it to? Nope, it doesn't. So I will go 19.03. 19.03 centimeters, because that's the length of that side, right? Okay. Taking a look at number 4, a parallelogram has two adjacent sides. Adjacent means right next to, with lengths 4 and 6 centimeters respectively. So parallelogram. So let's draw this thing. This is the two, again, parallelogram. Both sets of opposite sides have to be parallel, and they're also going to be congruent. So this is 4, and say this is 6, which also means that this is 4 and this is 6. If the included angle measures 52 degrees, this is obtuse, so it won't be that one. It's going to have to be this one here. If the included angle is 52 degrees, find the area of the parallelogram. Okay? So here's what I'm going to suggest doing. If we take this parallelogram and we cut it in half, look, that's just the area of this triangle, right? And these two triangles are going to be the exact same because they've got the same exact dimensions. So let's do the area of this triangle and double it. So area is going to equal 1/2 the two sides, 4 times 6 times sine 52. And then we're going to end up doubling this. So this whole thing times 2, right? So really this 1/2 and this 2 are going to cancel out. So the area is just going to be 4 times 6 times sine 52 if we want to save ourselves a step at least there. So 4 times 6, and then we do sine 52, and that should tell us the total area of this whole thing, 18.9. And this is centimeters. So the whole thing is 18.9 square centimeters, because again, like each one of these is going to be 9.45. Double that up, and that's your 18.9. Okay. All right, let's move on to number 8. A rhombus has an area of 50 square centimeters. So let's draw a rhombus. Remember, a rhombus is a squished square. So that means all the side lengths are the same, but they're not all 90-degree angles anymore because it got a little squished. Okay. That's not the best drawing, but you get the idea. So now the whole thing, the area of this thing is 50 square centimeters, and the internal angle size of 63. So we know that one of these is going to have to be 63. So it's probably going to be that one, right? Find the length of its side. So we know that these two lengths here, if we were to cut this in half, like we did the problem before here, if we cut this in half, we know these two side lengths have to be the same. And that's going to give the area of half of this. So if the whole thing is 50, we know that the area of this thing here, area equals 25 square centimeters, right? That's going to be this piece right here. So let's set this thing up with our area formula. So we know the area of that, just this triangle, is 25. It's going to be 1/2 our two sides, which is x and another x, and then sine 63. So the only thing we can do really over here is take half of sine of 63. So let's see what that gives us. 0.5 sine 63. That gives us 0.4455. So we get 25 equals x times x is x squared times 0.4455. Right? We want to get the x by itself, so let's divide both sides by 0.4455. Right? And that will tell us what x squared is. So look, that number, unrounded number, is still there. So let's do this. 25 divided by second answer gives us 56.12. And that is what x squared is. We don't want to know what x squared is. We want to know what plain old x is. So we square root both sides, and that'll tell us what our x is. So we do, let's do the square root of this unrounded number. So we'll do second answer, and we get 7.49. And that is going to be centimeters. Each side is going to be 7.49 centimeters. Super helpful to not use rounded numbers. Use the numbers that are still in your calculator, and then just round your final answer. You can round, like write down your rounded answers here just so you kind of, remember what you did, but keep those numbers that are not rounded in there, and just round at the very end. Because if you round all along the way, your answer is going to slowly get farther and farther off of what it should be. Okay? Okay, let's take a look at number 11. Australian 50-cent coin has the shape of a regular dodecagon, which is a polygon with 12 sides. Oops. 12-sided polygon. Each of those 50-cent coins will fit exactly on an Australian $5 note as shown. What fraction of the $5 note is not covered? All right, that's interesting. Let's figure this out. Okay, so let's do this. Let's figure out what the area of one of these things is. Now, they don't give us any kind of measurements for anything, which is actually okay. We'll make that work. So let's do this. Let's say if we take this right here, let's just take out one little chunk of triangle right here, right? And since it's 12-sided, there's going to have 12 of those triangles total, right? So let's just call this, I don't know, let's just call this, since there are no measurements, let's just make this easy. We'll call these 1, right? So let's redraw this triangle out here. All right, looks something kind of like that. This is 1, and this is 1, and we got to figure out what this angle is. Since we know that there's 12 total triangles, there's 360 degrees. Each of those 12 triangles are all going to share the 360 degrees. So we do 360 divided by 12, and we get that each one of those angles there is 30 degrees, right? So the area of one of these things here, area, is going to be 1/2 of b times c, which is 1 times 1 times sine of 30. Okay, so the 1 times 1 isn't going to do us anything, so really it's just going to be 0.5 times sine 30. 0.5 sine 30, and that gives us the area 0.25 of one of the 12, right? So that means that the area of this whole, one whole coin, we'd have to take that 0, so the area of one sliver, so the area of a coin is going to equal 0.25 times 12 of those, right? So 1/4 times 12 is going to give us the area of one coin is going to be 3, whatever these are. So let's just call it 3 units squared for the area of one coin, right? There's 1, 2, 3, 4, 5, 6, 7, 8. So the total area of coins, total area of coins is going to equal 3 times 8, 24 units units squared, 24 square units for all the coins. Okay, so now what we can do, now we just got to figure out what the area of this whole thing is going to be. Since we called this 1, if you notice, this right from, say, here all the way up to here, that's going to be a distance of 1, and down to here, that's going to be another distance of 1, down to the middle here, another 1, and another 1. So the height of this whole thing here, the height of this whole thing will be 4 units. And then, so really basically each coin is going to be 2 units, right? So there's 2, 4, 6, 8. So it's going to be 8 units wide. So we can figure out the total area of the bill by saying 4 times 8 is 32. Okay, so it says what fraction of the $5 note is not covered. So 24 out of the 32 is, so if we take 24 away from 32, that gives us 8 out of the 32 units are not covered, right? And then 8 over 32 reduces down to 1/4 of the bill is not going to be covered by that. Okay, now I realize that's kind of a tricky one. You got to do a fair amount of math to figure that all out, but figuring out something like that kind of feels good to solve a trickier problem like that. Okay, last one to take a look at here is 12. Find the shaded area. Okay, so to find the area of a whole circle, let's put these under here. This is going to help out. So area of a circle is going to equal pi r squared, right? Now, if this thing were to go all the way around, that'd be one full circle, but it only does 85 out of the total 360. So the area of a sector, we call it, is going to be the angle over 360 times pi r squared. Okay? So what we want to do is we want to find the area of this whole sector. Let's draw a picture to kind of get the idea. So we're going to do this. We're going to find this whole area here, and then we're going to subtract the area of just the triangle piece right here. Looks like that. And that's going to leave us with just the area of the shaded part. Okay? So this here is the area of the sector. This here is the area of the triangle. Subtract those two, and that will give us this shaded piece right here. So area of the sector on this one here, area is going to equal the angle 85 over 360, because it's 85 3/60ths of a full circle, times pi times our radius, which is 12 squared. Okay, and then we're going to subtract the area of this triangle here, which is this formula here, which is 1/2 b times c. These are both 12, so 1/2 of 12 times 12 times sine of 85. Okay, so we're going to want to calculate both of those, subtract them from each other, and we're in business. So 85 divided by 360 gives us 0.236 times second pi for mine, and then times 12 squared. And that gives us 106.8, we'll call it. Okay, and then we're going to subtract the area of this triangle here, which is 0.5 times 12 times 12, and then sine 85. And that gives us area of 71.2. Okay, so when we subtract those two, 106.8 minus 71.2, we get a total shaded area there of 89.6. And that is going to be centimeters squared. Of course, looking back at this, I'm put in 160.8 instead of 106.8, so let's try that again. 106.8 minus 71.2. Oh man, what happened? Let's try this. 106.8 minus 71.2 gives us 35.6. That looks a lot better than 89.6. I thought that looked a little bit big. So 35.6. 35.6 square centimeters. Okay. Our answer is a little different from the back of the book, probably because we did a little bit of rounding, but we should be good, unless I typed in something else wrong on the calculator. Apparently this one was supposed to be 71.7, so there's where our 35.1 is. Okay, so made a couple mistakes in there, but came back, fixed them. That's the important part, right? Okay, let's take a look at C now that we've taken up all the space. But C is going to be kind of the same idea here. We're going to want to take the area of the whole sector and subtract the area of the triangle to give us the shaded piece here. Okay, so let's do that same thing. So let's do C in red. So we're going to do area is going to be 135 over 360 times pi times our radius, which is 7 squared. And then we're going to subtract the area of our triangle here, which is 1/2 of the two sides, 7 and 7, because those are both the same, because they're both radii. And then sine of 135, right? So let's see if I can get this right on the first shot. Let's see, 135 divided by 360 tells us that it is 37.5% of a full circle times pi times 7 squared. Gives it, this is 57.7. I'm going to be really careful to write down the right number here. And then the area of the triangle here is going to be 0.5 times 7 times 7, and then sine of 135. That should be a pretty small number. Good, it is 17.3. And then we go through and subtract those two. 57.7 minus 17.3 gives us 40.4. And that's going to be millimeters squared because it's area, right? I got that one right on the first shot. That's good. Okay. All right. That's all we have for the 8B problems. If you have any further questions on these or anything else from the assignment, please feel free to ask. Thanks.